Week 10, EDM 60204, Measurement and Geometry. And in week 10, we are going to look at angles. So the learning objectives will be, at the end of today's lesson, you should be able to state the definition of angles, identify the device to measure angles, and identify and name the different types of angles. For example, we have acute, right, obtuse, straight, reflex, and full. And the last one is to identify the different orientation of angles in space, where we want to develop our students' spatial ability or spatial sense. Now let's recap last week's lesson. Because in last week's lesson, we did also learn a bit about angles, but the angles are used to identify parallel lines. Okay, so the first thing that we learned was a point. And then we learned about line. And then we learned about line segment, ray, perpendicular lines. And then under parallel lines, we use transversal line and different or special angles to determine whether the parallel lines that we drew are really parallel lines. So some of the angles that we used are vertical angles, corresponding angles, alternate interior angles, alternate exterior angles, and consecutive interior angles. Now these consecutive interior angles actually will add up to 180 degrees. So if you add up the two consecutive interior angles and they are less or more than 180 degrees, that is not parallel line. Okay, so you need to adjust the parallel line once again. Okay, let's look at devices. What do you use to measure angles? Okay, name the two devices you see in the next two slides. Post your answers in the comment box for week 10. So this is the first device, and I'm sure you have seen this before. Okay, you can find it in a geometry box. Okay, the geometry box that you actually bring along to class whenever we learn about geometry. Alright, so if you have already put in the name of this geometry device, let's look at it. So the name is 0 to 180 degrees protractor. Okay, protractor. So you can see inner, this is the inner. Okay, it starts from 0 on the right and it ends with 180 on the left. Now the other one, which is exterior, it starts 0 from the left and ends with 180 on the right. So whichever way you go, 90 degrees is always here. And then if you are measuring from this side, then let's say it is 30 degrees. But if you are measuring from this side, it is also 30 degrees. Okay, and then it depends on where you want to go. Now this next device, device 2, is also a protractor, but it is a 0 to 360 degrees protractor. Now the first one here and here is to show 0 to 180 degrees. And the outer ones are 360 degrees. Okay, so you can use either the 0 to 180 or 0 to 360 degrees. Okay, but most of the time we have the 0 to 180 degrees in our geometry box. Now, how do you define angles? Okay, what are angles? Okay, an angle measures amount of turn. Measures the amount of turn. So you can ask your students to think about this definition. Okay, so think of one activity that will remain with your students for a long, long, long time when they think of angle. Right? So what kind of activity will, be there with them until one of them or some of them become teachers and teach their students, and they still use that, and it is like it won't be called obsolete. Okay, so one way to do this is to ask your students to stand up. Let's say this is your student. And then ask your student to, do their hands like that. And they stay still. Okay, and then they only turn their hand. So you can have their hands turned this way. Okay, or you can have their hands turned this way. Right, so I think this first choice is much better. When you say, 90 degrees, so they will place their hand here, so it will be something like this. The hand will be here and here. Okay, so this is one activity where you can have different degrees for angles. Alright, let's get to know the angles. Okay, so the name here is due to the degree. Okay, the angle. So the first one is on the left, which is acute. Okay, which is acute. Acute here means small. So this acute is less than 90 degrees. Okay, this is acute angle. It is less than 90 degrees. That's why you have it like this. So if it is 89.9 degrees, it is still acute angle, as long as it is less than 90 degree. Okay, next one is right angle. So right angle down here, it is 90 degrees exactly. That's why we have the box here. So the box, the square box, actually tells us that it is 90 degrees. Obtuse. Okay, obtuse is an angle that is greater than 90 but less than 180. So you can see the 180 is supposed to be here, but it doesn't touch 180 degrees. It is still less than 180 degrees, but it is more than 90 degrees. Okay, now this is a straight angle. Straight angle because it is 180 degree exactly, so it's a straight angle. And then we have reflex angle. So the reflex angle is actually greater than 180 degrees. Okay, it is greater than 180 degrees. And then we have full rotation. Okay, we call it full rotation or 360 degrees. So these are the names that you must be familiar with. When you teach your students, you must know their angles. Okay, acute, we begin with acute, and then right, and then obtuse, and then straight, and then reflex, and then full. Okay, let's look at acute angles. So acute angles must be less than 90 degrees. So it could be 54 degrees, it could be 71 degrees, it could be 48 degrees, and so on, as you can see here in this picture. Now, apart from the angles being less than 90 degrees, you must also draw in different orientation. Okay, draw in different orientation. Okay, orientation here means position, like this one. Okay, you can draw it this way, you can draw it this way, you can draw it this way, or even this one here, which is very small, 12 degrees Celsius, 12 degrees and 67. So this will actually help with your mission to develop spatial sense in your students. A very simple way to remember acute angles is the word acute. The A is actually the angle. Okay, so the A has an acute angle. Alright, so which angle? This one you have to be very careful. You also have to highlight it to your students. Remember to look carefully at which angle you are asked to name, because the acute angle is the small angle, which is less than 90 degrees. Okay, so let's say you have this kind of drawing, okay, where the angle outside the acute angle is 311 degrees. This is a reflex angle. Okay, so the acute angle is actually the inside or interior. Okay, so which one are you looking at? Are you looking at the bigger angle, or are you looking at the smaller angle? So if you are looking at the smaller angle, this is definitely acute angle. But if you are looking at the bigger angle, it is a reflex angle. Okay, the next one is right angles. So when we say right angles, it must be exactly 90 degrees. So you can use the symbol, a square symbol like this one, to show it is 90 degrees. So sometimes it's enough to just show the square. Sometimes you need to write the angles. Okay, it really depends. Now note the special symbol like a box in the angle. So this is to symbolize right angle. So 90 degrees is barely written when you use this symbol. Okay, so if we see that the box in the corner, we are going to be told it is right angle. In squares, you have right angles. In rectangles, you have right angles. Okay, you can ask your students, where else can you find right angles? Can you draw it? Okay, so in a triangle, like equidistance triangle like this one, the right angle is here. Okay, alright, so about right angles, you can also draw them in different orientation. This is the one that's the normal way of drawing it, but these are different orientation. Okay, so this will develop your students learning on geometry, also spatial sense. Obtuse angles. Okay, obtuse angles. It is more than 90 degrees and less than 180, so it has a range. Okay, so the range is between 90 to 180 degrees, like this one, 130 degrees. Okay, and you can also draw it this way, but remember which side you are looking at. Are you looking at this side or are you looking at this side? Okay, so always remember it must be between 90 degrees and less than 180 degrees. Then you have different orientation drawn. Okay, so what you can do with this kind of activity is for your students to use their protractor and then find the angles. Okay, find the obtuse angles. So you might have smaller angles, acute angles, right, or 90 degrees, okay, right angles in the mixture. So once again, which angle are you looking at? So if you are looking at this side from this angle, this is obtuse. If you're looking at the bigger one, this will be the reflex. Alright, next we go to straight angles. Okay, straight angles is 180 degrees. It must be really 180 degrees. And you can change them, their orientation. That means you can draw it this way, you can draw it vertically, you can draw it horizontally, you can also draw it upside down. Okay, so this, again, the different orientation will help to develop spatial sense. Okay, reflex angles. Okay, reflex angles are the bigger angles in the angles that we have mentioned. So it will be like this. Okay, the smaller one here will be obtuse. So you bring in obtuse angles with reflex angles and see if your students are able to identify them. Okay, so it is very good if your students can identify acute angles, but we're not looking at acute angles, we're looking for reflex angles. There is an obtuse angles, but we're not looking at obtuse angles, we're looking at reflex angles. And again, different orientation, which is good. This will help with your students developing their spatial sense. Okay, so which angle you are asking your students to measure or to name, you have to show it to them. Meaning to say, if you have something like this, then okay, draw this line and name this A. Okay, so name the angle A. Okay, don't just draw something like that and then there is no indication of which one. Your student might think that this is the one that you want. Okay, so yeah, so here we see we have the acute angle and we have the reflex angle. Of course, the reflex angle is larger than the acute angles. And then we have obtuse and we have reflex. And reflex angle is larger than obtuse angle. Okay, full rotation is 360 degrees, one whole round. Okay, or we call it revolution, or we can call it complete turn, or we can call it full circle. So there are so many names for full rotation. It depends on the book that you will be using when you are teaching in the school, in your own school. Okay, all right. So just remember some of the names here, which means a complete circle. Sorry. Which means a complete circle. Okay, full rotation. This image of a protractor shows that is a full rotation of 360 degrees. Now, if you don't have the 0 to 360 degrees protractor, it's okay. Just find 2. Okay, 0 to 180. So you can place them up here. Then let's see, I'll use another color. Place another one down here. So you will get 360 degrees protractor. Okay. And half a rotation is 180 degrees, is called the straight angle. And a quarter of a rotation, quarter, this is half, this is quarter, is 90 degrees and it's called right angle. Okay, you can have quizzes where you can ask your student, what is the degree for straight angle? What is the degree for quarter angle? So that way they are using the knowledge that you are giving them when answering the questions. Okay. Alright, so in a diagram, in a single diagram, you put everything together and you have this. It's rather cute. Okay, you have this. So we will start from right and then we go all the way around. Yeah. Okay, So from the right, the first stop will be at acute. Okay, so you have to remember acute must be less than 90 degrees. And then we have right angle. Okay, so the right angle is actually 90 degrees. And then we have obtuse, which is between 90 degrees and 180 degrees. This is obtuse. And then we have the reflex, which is more than 180 degrees. Right? Then we have the reflex. So AROB. Okay, R. What am I doing? Sorry. AROR. Okay, X, for example. So RORX. So you can give this simple name, or you can write a silly sentence so that your students can remember. Okay, like for example, apple, row, RX. Okay, so maybe it's a name of bicycle or something. Right, so this is how you remember the different angles in this lesson. Okay, more about angles. Right. Now these are special names for the different types of angles. Remember that in the last lesson we have special names for special angles when it comes to parallel lines. Okay, so we have interior and we have exterior. Here we also have interior, we have exterior as well. Let's have a look at them. So the first term or the first special name will be congruent angles. Congruent angles, okay? So congruent angles actually have the same angle, okay, in degrees. We don't use radians. That's it. So if you see two angles that have the same angles, they are also called congruent angles. Okay, and try to remember what we learned in last week's lesson, okay, for parallel lines. There are a lot of congruent angles because they have the same angles. Okay, so here congruent means the same. Okay, means the same. These angles are congruent, 110 degrees. Now they don't have to point in the same direction. This is good. They don't have to point, in the same direction. You can have that kind of angle here, like this, like this, like this. As long as you see that the angles are the same, then they are congruent angles. They don't have to be on similar sized lines. Some might be big, like this, maybe, and then some might be small, as long as the angles are the same. So, just the same angles. Okay, remember the word congruent means same. Okay, there you go. Congruent means same. Alright, angles around a point. So angles around a point will always add up to 360 degrees. And then we have, this is one point. Sorry, this is the point. Then we have 80 degrees, 53 degrees, 87 degrees, 180 degrees. Okay. So here we can see that when you add up, it will add up to 360 degrees. So if you're looking at angles around a point, then you need to add up everything. But if let's say this one is x, then you need to find x here. Okay, so how do we do that? Okay, so we have x plus 80 degrees plus 58 or 53. Oh, sorry, 53 degrees. 53 degrees plus 87 degrees equals to 360 degrees. Then you can find x, which is 140 degrees. Okay. Right. So because like what the example that I gave you, we can actually find an unknown angle. Okay, so here the unknown angle here is C, and we know that the total angle is 360. Okay, 360. So the process is very important. So what do you do? First of all, you need to tell your students to sum of the known angles. So here 110 degrees, 75 degrees, 50 degrees, and 63 degrees will total up to 298 degrees. And then the angle C is 360 degrees minus 298 degrees. It will give you 62 degrees. Okay, there is one suggestion from teachers teaching other programs. Okay, so they would like, because international school kids, when they learn maths, they are given the opportunity to solve the problems on their own using a different method. So let them explain it to you how they're doing it. Okay, but remember the process is still there. Okay, so they must show you the process. So you show them that it is until here where you add all the existing ones, okay, angles. So how do you find angle C? So don't show them this yet. So how do you find angle C? Let them think. That way you will see several new ways of finding angle C, and then ask them to create a short video. For example, if they're using iPad, ask them to create a short video how they solve that problem, and then you can put them into a into the learning management system so that everyone else can take a look at it. That is how we learn. Okay. All right, angles on one side of a straight line. Okay, angles on one side of a straight line. So this is a straight line, the blue line here. So we are looking at the top part. Okay. Now, straight line means 180 degrees. But then we have two different angles. One is 150 degrees, the other one is 30 degrees. So this 30 degrees, this one here is acute. Okay, acute angle. And what is the name of this one? Can anyone guess? It is obtuse. Because obtuse is more than 90 degrees and less than 180 degrees. Okay. All right. So it depends on which side you're looking at. Okay. Again, on angles on one side of a straight line, you can find the unknown angle. Okay, or an angle which you don't see the angle. Right, so here you need to find angle A. Okay, you need to find angle A. And once again, ask your students how they are going to solve this. So they will start thinking in their groups, okay, how are we going to do this? What is it that we need? What are the information given? What do we need to find, and how are we going to find it? Okay, so then they can actually show you the way that they solve the problem. Okay, same case with this. What is angle B? The angle B is here, and now we have three different types, okay, of three different angles. So then ask them, how are you going to find B? Okay, we have, I mean, like I've shown you three examples, and for each example Okay, I don't say this is how you're going to use it. So keep on asking, how are you going to find angle A? How are you going to find angle B? This actually helps them with their critical thinking and also geometric reasoning. They will need to reason out, okay, why is it that at the end, after we have solved the problem, angle B is 72 degrees? Have we done it right? Okay, so they are going to check the process. Teach them how to check the process instead of checking the answer. Okay, now you yourself, if you have never done this before, right, try a couple of exercises so that you are used to it, and when you go to class you can ask your students and you know that they can do it. Okay, now the next angle is called supplementary angles. Okay, supplementary angles. Okay, supplementary angles is that they add up to 80 degrees. They add up to 80 degrees. Okay. Okay, supplementary angles. Angles means there are two angles. Okay, so they will add up to 180 degrees. Now congruent angles means they are the same, so there's no adding up of anything. Okay, so here for example we have 40 degrees and we have 140 degrees. So when you add them up, it must be 180 degrees. If it is more than 180 degrees, this is not supplementary angles. Okay, not supplementary angles. So here, they make a straight angle. For this example here, this is a straight angle. But the angles don't have to be together. This is something new. Okay, they don't have to be like this, where they need to be next to each other. They can be separate, like these two. One is 60 degrees and one is 120 degrees. But these two supplementary angles, when you add them up, it is 180 degrees. Okay, so give your students more exercises on supplementary angles so that they are confident in finding supplementary angles. So you can have one piece of paper, you have so many angles, and then ask them to find supplementary angles. Which one? Okay, so they can use color pencils. Okay, so they color the angles that they think are supplementary. Okay, like for this one, let's say I just use yellow. So I just color like this. Oops, and then color like this. So these are supplementary angles. So ask them to color the angles. Okay, maybe not like this one, but you can color the angles here. Okay, color the angles like this. So you know, oh, okay, so they take 60 plus 120 is 180. So these are supplementary angles. And then you might have others like 20 degrees, and then you have 150 degrees, and then you have another one 160 degrees. So which one will be the supplementary angle? So you color this one and this one. Okay, so 160 plus 20 will be 180 degrees, but not this one, right? Okay, so that's how you would want to give exercises to your students which are fun, where they can color, is colorful, and they can remember better. Okay, interior angle. We are still at supplementary angle where you add up to 180 degrees. So an interior angle is an angle inside a shape. Angle inside the shape. Okay, so for example, you have this one here where the interior angle is 30 degrees and the exterior angle is 150 degrees. When we want to add interior angle and exterior angle, we need to get a straight line. Okay, so straight lines, as you can see here, straight lines, straight lines, straight lines. Okay, and the total must be 180 degrees because of the word supplementary. Okay, supplementary angles. All right, exterior angle. So when it is exterior angle, we are looking at the part where it is 150 degrees. Okay, now normally they will tell you which one is exterior, which one is interior. If not, you name it yourself, because normally the bigger one will be the exterior. So this is 150 degrees. Okay, so when we add up the interior angle and exterior angle, we get a straight line of 180 degrees. Okay, let's look at interior angles for triangles, quadrilaterals. Can you still remember what quadrilaterals are? Can you? Very good. Quad means 4. Laterals means sides. Okay, so 4 sides. All right, let's look at interior angles of polygons. And polygons, they have more than 2 sides. They will make shapes, 2D shapes, but they must be a closed shape and they are flat. So an interior angle is an angle inside a shape. All right, so if you have this kind of drawing, this they say interior, that means it's inside. This is exterior, that means it's outside. So to show it's interior, they draw this triangle. Okay, they draw this triangle. So for a triangle, interior angle will total up to 180. Okay. All right, these are triangles. Okay, so triangles, all the angles will add up to 180. So it's easy for us to remember. So if you have this kind of triangle, the first angle is 60 degrees, 90 degrees. Okay, this is a right angle triangle, and then this is 30 degrees. So you add them up and you get 180. Now if you get this kind of triangle, which is not a right angle triangle, it could be a scalene. Okay, so you look at the angles inside, you add them up, and it is 180 degrees. Okay. All right, now when we know the total angles in a triangle is 180 degrees, that means we can find an unknown angle in the interior angles for triangles. Right. So before we do that, let's look at interior angles of polygons for quadrilaterals. Okay, quadrilaterals, they have 4 sides. Any 2D shape that has 4 sides, like squares, rectangles, rhombus, trapezoid, kite, diamond, and so on. Okay, so quadrilateral has 4 sides, and this is a square. So a square will have right angles for all 4 sides. So it will have 90 degrees, 90 degrees, 90 degrees, 90 degrees. You add this up, it will be 360 degrees. So for quadrilaterals, okay, quadrilaterals, you add up all angles, it will be 360 degrees, like this. Okay, so interior angles for quads will be 360 degrees. Now this is a trapezoid. So trapezoid or trapezium, you look at all the angles inside. and you add them up, it will give you 360 degrees. Okay, so for any quadrilaterals, the total interior angles will add up to 360 degrees. Okay, with this information in mind, you can then find unknown angles in any quadrilaterals. Okay, let's look at the interior angles of polygons. Okay, in a square, this is a square. You can also ask your students to prove this. So they draw a square. They have to measure the length and the width first, and then they will measure the angles. Then ask them to draw the line, this line. Okay. After that, ask them to measure the angles here. Are they really 45 degrees? Then ask them to cut. Okay, ask them to cut. Then they have a triangle. Okay, so triangles, like right angle triangles, actually comes from, or you can make them from a square. So the interior angle, okay, interior angles, when you add them up for quadrilaterals, will be 360 degrees, and when you cut them into half into triangles, it will be 180 degrees. So this is when your students will be able to see, oh, now I see where they get the 180 degrees from. It's interesting. Now for interior angles of polygons, we are looking at pentagon. Okay, pentagon has 5 sides. Okay, 5 sides, as you can see. 1, 2, 3, 4, and 5. So 5 sides. Okay, so a pentagon with 5 sides can be made from 3 triangles. Okay, so you know its interior angles add up to 3 times 180. So this will give you 540 degrees. Okay, so each triangle, okay, let me just show you. This is the first triangle. Okay, this is the first triangle. This is the second one. Okay, and then this yellow one is the third one. Okay, so I'll just draw it like this. So you see that for each triangle, the total interior triangles, total interior angles will be 180. So for this side, we have 36 degrees plus 108 degrees plus 36 degrees. Okay, and then for this side is 36 degrees plus 108 degrees plus 36 degrees as well. In the middle section, we have 72 degrees plus 72 degrees plus 36 degrees. So you can see when you total it up with your calculator, it will actually give you 180. So this is 180 degrees, this is 180 degrees, and this is also 180 degrees. So when you add up the interior angles from these 3 triangles, you will get 550 degrees. Now, if 550 degrees you divide by 5, okay, because of the 5 sides, you will get 108 degrees. Okay, so that means, okay, let's see, you will have 36 degrees plus 36 degrees plus 36 degrees. Okay, so 36 degrees plus 36 degrees plus 36 degrees. Okay, so this will give you 108 degrees, right? So that means each angle, if you are not looking at the triangles, okay, this is the angle for the pentagon. It is 108. This is 108. This will be 108. This will be 108. This is also 108. Okay. So always remember, for the pentagon, the total will add up to 540 degrees. Okay, so here are a list of interior angles of polygons. Okay, so we'll start with triangle. It has 3 sides. The sum of interior angle is 180 degrees. The shape is like this. Okay, and each angle is 60 degrees. Okay, what is the name of the triangle shape? Equilateral triangle. Okay, equilateral triangle. So equilateral triangle here means that the sides have the same length. This side, and this side. Okay, quadrilateral. Quadrilaterals, they have 4 sides, and the sum or the total of interior angles is 360 degrees. And this is an example of a quadrilateral. Each angle is 90 degrees. Okay, when you look at the angle, each angle is 90 degrees. That means this is going to be a square. So it is regular polygons. Okay, regular polygons. Alright, for a pentagon, it has 5 sides. Sum of interior angles is 540 degrees. And this is the shape of a pentagon, where it is also a regular polygon, where all the sides will have the same length. So each angle, okay, each angle in a pentagon is 108 degrees. For hexagon, it has 6 sides. The sum of interior angles is 720 degrees, and you can see that the shape is like this. It is a regular polygon. Okay, regular polygon. So that means all the sides will have the same length. This side, this side, this side, this side, this side, and this side. Hepta or septagon. So in chemistry, we normally will call it heptagon. It has 7 sides. The sum of interior angles will be 900 degrees. And you can see here it is a regular polygon as well. Okay, so all the sides will have the same length. And the angle, each angle in a heptagon is 128.57 2 decimal places. Okay, and then octagon is 8. The sum of interior angles will be 1080 degrees. This is an octagon. Okay, all the sides will have the same length. Each angle is 135. Nonagon is 9 sides. The sum of the interior angles is 1260 degrees. This is how it looks like. All the sides will have the same length, and each angle is 140. Okay, 140. Now down here, you will have the formula for any number of sides. Okay, for any number of sides. Okay, interior angles of polygons once again. The sum of interior angles will be n minus 2 times 180 degrees. Okay, so each angle of a regular polygon is n minus 2 times 180 divided by n. So this is the angle of one angle. So each angle, and this is the sum. Okay, so the sum of interior angles will be shown as this formula, n minus 2 divided by 180. But each angle, okay, regular of a regular polygon, n minus 2 times 180 divided by n. So n is from, okay, n equals to 1, 2, 3. But of course, the most number will be from 3. Example, what about a regular decagon? Okay, decagon means it has 10 sides. So we use this formula here, n minus 2 times 180 degrees. So n is actually 10 minus 2 times 180. So this will give you 1440 degrees. So that means the sum of a regular decagon, the sum of angles of a decagon will be 1440 degrees. And this is only for regular decagon. Okay. Now, each interior angle, we want to find angle, each angle is 1440 that you have counted. Okay, divide by 10. So it is 144 degrees. So that means for each part, each angle here will be 144 degrees. Okay, so decagon will have 10. So that means this is how you use the formula shown here. Okay, so write down the formula, paste it on your whiteboard, and then have a look at it every day. Okay, we have finished with interior angles of polygons. Let's look at exterior angles of polygon. Now this is a polygon, this is a triangle, and this is the interior. The exterior will be this side, okay, which is outside of the interior triangle. As you can see, how do we find the angles? So what you need to do is just to use a ruler, draw a straight line all the way out like this, and then this will be your angle, the exterior angle. So we have 3 because this is a triangle. So we have here A, and then B, and then over here we have C. Okay, so we have 3 exterior angle for exterior polygons. Okay, so let's have a look at this. Supplementary, okay, remember, for interior, supplementary is when you add up all the angles and the total is 180 degrees. For exterior, it is the angle between any side of a shape and a line extended from the next side. Okay, so here we have the interior, and over here will be the exterior. So the exterior angle here is 150 degrees. Okay. Now, for polygons such as this one here, this is a pentagon. Okay, 1, 2, 3, 4, 5. So it's a pentagon. So how do we find the exterior angle? You just extend each side, you extend. Okay, each side you extend. Just like that, you extend, and you extend. Oops, okay. And then between the side and the extended line, this is the exterior angles. Okay, this is the exterior angles. So in other words, the exterior angles add up to 1 full revolution. 1 full revolution means it is 360 degrees. Okay, so you can go to this particular website and you can click on the button, okay, to play it. So if it is a square, this is a square, okay, not so accurate, but this is a square. So you need to extend it. This is one, then you extend another one. Now if it is a straight line like this is 180, it's not counted. This is the exterior angle. Okay, so extend over here, this is 90 degrees, extend over here, this is 90 degrees. So 90 plus 90 plus 90 plus 90, 360 degrees. Okay, now this is hexagon, this is hexagon. So for this hexagon, again, extend, 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 and extend. And then the angle, the exterior angle will be outside here. Okay, between the side and the extended line. Okay. Okay, so we have looked at supplementary angles for exterior angles, okay, exterior polygons. Now let's look at complementary angles. So complementary angles, okay, we have one angle over here which is 50 degrees, and another angle over here which is 40 degrees, and so 40 plus 50 degrees equals to 90 degrees. Okay, so complementary angle for exterior angles will add up to 90 degrees. Okay, will add up to 90 degrees. Okay, so let's have a look at this. This is a right angle, and we have two angles here. One is 40 degrees and one is 50 degrees, and these are what we call as complementary angles. Okay, because when they add up, they will give you 90 degrees, just like as being shown. But the angles don't have to be together. Okay, again, they don't have to be together. They can be separated. They don't have to be together. They can be separated. So like this one, it is 27 degrees. This is acute angle, and this is 60 degrees, 63 degrees. Okay, this is also an acute angle. Okay, an acute angle. So when you add these two together, 27 plus 63, sorry, it will give you 90 degrees. A right angle triangle, in a right angle triangle, the two non-right angles are complementary, because in a triangle, the three angles add up to 180. So 90 degrees had always been taken by the right angle. So that means this side and this side, 22 plus 68 degrees. Please don't forget the symbol there is 90 degrees. Okay, so the symbol for degree, for angle, for the degree is this one. So please do write this one. You don't write this one, I don't know whether you are, what unit are you using? Okay, what unit are you using? Are you using centimeters? Are you using kilometers? Are you using grams? So the unit is compulsory. Okay, unit is compulsory. That means if you don't put the unit there, even though your answer is correct, like this one, you get 0 marks. Okay. So when two angles add up to 90 degrees, we'll say they complement each other. Okay, so complementary comes from Latin completer, means completed. Okay, because the right angle is thought of as being a complete angle. Oh yeah, the spelling. Spelling of complementary is complementary. This is not that complementary angle. Okay, so what does this mean? Think about that. Okay, let's look at supplementary versus complementary angles. So supplementary angles will add up to 180 degrees. Complementary angles will add up to 90 degrees. Okay, so that's one difference, okay, between complementary and supplementary. The other one is that for complementary, like because of the letter C is a corner, So when you draw it, you sort of like that, and then you have this. So this tells you it's a complementary angle. But for supplementary angle, because when you add up, it is 180 degrees. So it's a straight line. So supplementary straight line. Okay, so it looks like that. Or you can think when you are right, you get a complement. So the complement is this C here. Okay, supplements like vitamins, okay, so something extra. Okay, so you can think of ways to remember the complement versus supplement angles. So, do you have any questions? If you do, you can always type it in the comment box. If you don't, let's go to the next slide, where you need to show me that you understand what you have watched in this video. Please create a poster or design a poster. You can use Canva, you can use Pictochart, as long as it's a poster for week 10 lecture. This is a proof of or evidence that you have watched and understood today's lecture. Please post the link in the GC comment box. Okay, comment box. Individual work though. Okay, individual work. Right? Okay, that's all. I'll see you during our lecture.